Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR Hyderabad. Previously we discussed about the block diagram, what are the basic elements are available in the block diagram, and also one of the example based on the block diagram reduction rules we are going to calculate the transfer function. All these are we learned for the previous session, but today I am going to derive the or else calculate the transfer function by using the block diagram reduction rules. One more example I am going to consider, and I will explain the what are the block diagram reduction rules are going to be used on that particular problem. Now let's move on to that problem. Here this is the example 2 problem I am going to consider. This is the block diagram. I am going to reduce this block diagram into the single block, that is the transfer function of the block diagram. Here see, here R of S is our input and Y of S is our output. Here how many feedbacks are there available, and once see which rule is going to be applicable here. Just observe here, by see here G1 and G2, these two are in the connection of series connection or cascade form. So now we are going to apply the reduction rule, that is combine the series blocks into the single block. Means here G1 G2 are combined into the single block. Just to see, observe in the next. Here see, from this I am getting like this. Here the rule 1 is G1 G2 are the cascaded form, these two, and also here these two are the feed forward paths. G4 G3 are the feed forward paths, means here signal passing through the G4 and enter into the summing point. Here G3 signal is enter into the summing point. Both signal G4 G3 both are the enter into the same summing point. The direction is same, so these two are going to be added. So here G4 plus G3 or G3 plus G4, this is the one rule, and these G1 G2 are the cascade forms, going to combine these two G1 into G2. This is the one more rule. And also here these two rules, just see for the next slide. Here G3 G4, right, from that G3 G4, G3 plus G4 and G1 G2, we got the two by using the two rules. Here rule 1, blocks G1 G2 are in the cascade form, and rule 2 is the blocks G3 G4 are the two feed forward paths. Now just to modify that too, and finally we get this circuit from this. And also here observe, this is the one, and also here this one is, and here this one is the feedback path, right? This is the completely feedback path. See, observe, these two are in the feedback. Here signal is passing through G1 G2 and again feedback through the H1. Feedback signal is available and again enter into the same summing point here. So this is the rule we are going to use to eliminate the negative feedback. Here then a feedback signal is end with the negative symbol, so negative. So we are going to eliminate the negative feedback element or negative feedback block diagram by using the block diagram reduction rule. Here just this one is going to be eliminated. Now finally we get here, see, G1 G2, here G1 G2 into H1 divided by G1 G2 plus G1 G2, 1 plus, here minus is there, so finally we get the 1 plus G1 G2 and H1. In numerator G1 G2 divided by 1 plus G1 G2 H1. See here the next slide. See, observe, G1 G2 divided by 1 plus G1 G2 H1, right? Next here see one more thing. Here H2 is there. This is the feedback signal. Now feedback signal is moved to the next block of the G5. This is a take-off point. Moving to after the G5 block. H2 is moving. So what is the value of in this block G5? that value is considered or denominator into the H2 value. Here see, observe the next slide. Here H2 divided by G5 and here G5 is. So for that G1, G2, this is the eliminated. After finally we get the negative feedback value transfer function, and here after the take up point moving after the G5 we got this in feedback is H2 divided by G5. Just observe here G3, G4 and also G5, these are in the again cascade form, right? G3 plus G4, this block as well as this block, these two are in the form of cascade. Now we are going to apply the eliminate the cascade blocks, that is the block diagram reduction rule, right? See here, use rule 1 for blocks G3 plus G4 and G5, these two are in the cascade form. Now we are going to modify these two are combined into the single block. Next here observe just single block, here G3 plus G4 into G5, it is in the single block. Here observe, after any rule here going to apply for this circuit, just observe from this one is the gain and here also one gain is there, again it is a feedback to the negative feedback. Here now we are going to eliminate this negative feedback. This is one more chance or one more rule we are going to apply, this one also. And also after that here see, this one is after combine this block value, just to simplify, this one is now we are going to consider or we are going to eliminate the negative feedback. This is the negative feedback from here to and here finally end with the negative symbol. So this is the negative feedback. Now for this eliminate by this negative feedback, finally we get this circuit, finally we get this value G3 plus G4 into G5 divided by 1 plus here minus, end with the minus, negative feedback, so positive 1 plus this G3 plus G4 into G5 gain divided value divided by 1 plus these two are multiplied, just this one multiplied, G3 plus G4 into G5 divided by G3 plus G4 into G5 and H3, this is the value. Next observe, here again these two are in the form of cascade, right? These two blocks are in the form of cascade. So now we are going to apply the block diagram reduction rule. That rule is just to eliminate the cascaded blocks, this block and this block, these two are in the form of cascade. Now eliminate these cascade blocks into the single block, just to multiply these two block values. Just observe here, multiply these two block values, finally we get this value G1 G2 G5 of G3 plus G4 divided by 1 plus G1 G2 H1 of 1 plus G3 plus G4 and G5 H3, this is the value here after eliminate or after eliminate of this cascade block, finally we get this value, right? Again observe this circuit, this block diagram, is there any rule is applicable for this eliminate? Here just observe, this is a signal passing through this block and again feed forward or else forwarded to or feedback to the, this signal is again feedback to the feedback signal H2 divided by G5 and again enter into the reference signal, here input summing point. So this is also, this one is the positive feedback, end with the positive, end with the positive, so negative, this is the feedback is end with positive, so this is the positive feedback, so positive feedback. Now we are going to apply the rule, block diagram rule, that is eliminate the positive feedback loop. See here, the blocks are connected in feedback loop, okay na? These blocks are connected in feedback loops. So now we are going to modify these blocks or eliminate the positive feedback rule, finally we get this value here, this one, these two block values are multiplied in denominator, 1 minus, here place is there, so 1 minus these two values are multiplied and numerator part same value G1 G2 G5 G3 plus G4 divided by this complete block value divided by 1 minus these two block value multiplied. Finally, we get this value. This is the single block. After conversion, block diagram reduction rules to single block diagram, which is the transfer function. Therefore, finally, the transfer function of this block diagram is, transfer function is nothing but the output to the input, right? So, the ratio of output y of s divided by the ratio of input. So, transfer function is here, observe, y of s divided by r of s is equals to, this is the transfer function of the given block diagram. G1, G2 and G5 square of G3 plus G4 divided by 1 plus G1, G2 H1 of 1 plus G3, G4 and G5 H3. Next, G5 minus G1, G2, G5 of G3 plus G4 and H2. This is the final transfer function of the given block diagram. Here we are using the cascaded blocks, reducing the cascaded blocks and negative feedback loop as well as positive feedback loop, and also take up point moving after the block. All these are the rules are applied to this given block diagram. Finally, we get the transfer function of the given block diagram. This is the final transfer function. So here just observe from the first onward, just given block diagram, which rule we are going to apply here? Cascaded blocks, these two, G1, G2. So cascaded series eliminated. This one is the feed forward path. Here just two signals are entered into the here. So parallel or feed forward. Series, parallel blocks are eliminated. In the next step, just observe here, this is the negative feedback. Eliminating the negative feedback rule, we are going to apply here. Finally, we get the value is here, and also here take up point is there. This take up point is moving after the G5 block, after the G5. So in denominator of this feedback value H2 divided by the block value is denominator G5. So that's it. Next here, from this here, these two are again in series. So now we are going to apply the rule, which is eliminate the series blocks. Finally, we get the G5 of G3 plus G4, and after that, finally, this is again in the form of negative feedback. Now, negative feedback loop going to be eliminated. Finally, we get this block value, and again these two are blocks in the form of series. So now we are going to apply the rule of eliminate the series blocks. Finally, we get this value. So now again these two blocks in the form of positive feedback. Now we are going to apply the positive feedback elimination rule. Finally, we get this value. This is the block transfer function value. The transfer function is output by input. That is final. This is the transfer function of the given block diagram. Thank you all.